this time I want to sit down and talk. We had some requests, and we've actually sort of talked about this on the fringes over the years. I think it makes sense to have a presentation specifically on talking about the challenges and the uniqueness of dealing with testing a database and maybe some potential automation around that. The best thing we've talked about prior to this for doing a lot of this kind of work, and you can see a lot of those discussions, was when we talked about Django. Within Django Python projects, you have a really nice way to maintain your database through code. We talked a little bit about some of the scripts and some ways to essentially rebuild a database on the fly. Similar tools, if you use, if you're in the PHP world, if you use Laravel, it has some of that. There's definitely a couple of different Java libraries that you can do some things like that. There's C# related stuff. So if you want to do a little more maintenance of a database within code for a specific language, you can always Google it and look for the related tools. That's not something specific we're going to cover this time. We're going to look more at general purpose considerations and things like that for database testing. Specifically, we're going to talk about first some of the database testing challenges, the things that are a little bit unique to dealing with the database, and then get into some of those details. One of the main things in a database that you want to test is making sure that the structure and data integrity are maintained. Key is being able to save and load your data correctly and consistently and reliably. Some of the more, we'll call them advanced topics, I guess, in the world of database of triggers, constraints, and keys. And then sort of wrap it up talking about how do you put all this stuff together so that you can have some sort of a regression test or some way to repeat your tests with the database. So first, let's look at some of the challenges that are a little unique to database testing. The first one is that it's not just a functionality thing. So typically when you're testing code, you have some inputs and you have an output, and that's all you have to worry about. Databases are almost by design, by nature, in a lot of cases, it's a side effect that you're actually looking for, because you're going to have some inputs. Those inputs are going to either change or store or remove data, somehow monkey with the data in a database, and then you'll get some sort of output. Well, this thing, the output may be 100% correct, but then you need to still verify that the changes that were supposed to be done in the database were done. So it's you're almost testing side effects, which makes it a little less direct in how you do things. Often in a database, probably one of the biggest challenges is that our testing leaves a trail, whether that's through audit logs or whether that's through data that we create and then update. We have to somehow deal with that data. We don't want to have our test data sitting in a production database, for example. And so part of that is cleaning up. We have to have some sort of a mechanism to go in to test and to essentially remove our work, so our test doesn't leave a mark on the data. A clean test environment can be very difficult. You need, in some cases, you need data that is not does not have like patient information or personal identifying information or any sort of like financial IDs and stuff like that. And they have to be, in some cases, the challenge is it has to be a certain format, but it can't be valid. For example, a credit card number. Now, there are test credit card numbers that are out there that you can use for such things, but still, there's sort of a limit to how often you can use some of those, and without repeating your data. And then again, we get into you don't want to mess up the production data. You don't want to have stuff out there that people may think is production data. They may think it's real, even though it's test. And then you have to be able to, in some cases, it's how do I build this from scratch, which is also sort of the reproducing steps. It's like, hey, if I want to put this database on a new machine. Is that even possible? In some cases, it's not. In some cases, the database is this living thing that nobody can actually build it from scratch anymore. It's just a bunch of changes that have gone on. And other than, dump the database and import it somewhere else, and sometimes even that's really challenging, you don't have a way to have a test environment versus a production environment. Data integrity. So how does our data interrelate with data within the database? So let's talk about data integrity. What is it? You'll hear about it when you're dealing with the database, but what does that mean? Well, first, it means that the data is of a type that makes sense. For example, if you're dealing with financial transactions, those numbers need to be, probably 2 decimal float type, or two decimal precision, like a decimal, a float, something along those lines. If it's an integer, you're going to lose information. If it's a string, then it may be very complicated to do the kind of work you need to. If you're building a general ledger for an accounting system and all your numbers are actually stored as strings, or maybe even something more complicated than that, then you're going to have all kinds of issues in equating values, searching for values, things of that nature. We also need to have, with data integrity, so it's the type, but it's also that when we have relationship data between tables, that those are consistent. And this often is going to be in foreign key relationships. So for example, let's say you have a person record in the database. You have a table for people, and then people can have multiple addresses. Well, the way that you link that is the person record will have somewhere a list of address IDs that it can go get specific address information based on those address IDs. It could be 1 for your home address, 83 is your work address ID, and then some other number, and those, something else is your vacation home ID. And so when you're searching for data for that person, you're going to go over to the address table and you're going to go grab for those IDs, you're going to grab the address. Well, part of data integrity is that ID is pointing to a valid and the correct address. So you can't just go in. If you go in and just change the address ID for that user from 1 to 2, that may be a completely wrong and different address. It could even be invalid. So one, you have to make sure that it actually exists. You don't want it to just go off, be a non-existent ID. So if I have an ID of 1 for my address, I better have a record in the address table that has 1 as the ID. And then 2, it needs to be correct. It needs to be the right one. And you'll see this in the results of testing of data sometimes when there's like a hard-coded value or something like that, and you'll see that the IDs are not what they should be. It's not generating new IDs. It's not pointing to the right ID. It may not even be storing the right value. So maybe it's storing the ID to the phone table in the address column or vice versa, things like that. Along with this, we need to maintain the integrity with relationships, which is, we'll talk a little bit, but it's the idea of cascading and things like that. So if I delete an address record, then I need to make sure that I delete the pointer to that address record in the person table in my prior example. If I delete that person, I probably need to delete those 3 address records that were tied to that person. Otherwise, I have orphan records. I have these things that nothing refers to, and it becomes just junk trash data that's sitting out in the database. So we need to make sure that our data puzzle pieces to build whatever, whether it's a picture of a person or it's a some sort of a contract or business transaction or whatever it is, we need to make sure that all of the pieces of data that we need to use to create that construct fit together properly, that they have the right IDs, that they have the right types, and that you can recreate it. So if this is the saving and loading idea, if I save my data for a person and all of the related stuff, then I need to have all of those relationships and the data integrity put together so that I can also come back and query the database and get all of that data back. It's one thing to save it. It's another thing to be able to reliably pull it back out, to load it from the database. So it's a key part of our testing.
Hey, Rob, before you jump ahead, I got a quick question on that.
Sure.
So if you go back to slide. So with the data integrity, would you also include data encryption with this for like HIPAA and PCI compliance?
Yeah, actually, that's an excellent question. It's not something I specifically have called out in this presentation. So that's an excellent question. Good point. Is you need to be able to, it is similar to what you saved. You need to be able to load back, but there are a couple of different ways that things can be encrypted when you store it in the database. Sometimes it's encrypted at the database level. Sometimes you encrypt it going in and you decrypt it coming back out. And you need to ensure that if you encrypt something and put it into the database, then you need to be able to either decrypt it when you pull it back out or reliably encrypt the same string and be able to check it against that value. And for that example, I'm thinking about passwords, because typically what happens is we will encrypt a password, and essentially it's a one-way encryption or some sort of hash where we can't find out what that password is. There's no way we can go back and figure out what that password was originally. But what we can do is we can take a string and encrypt it and say, does that encrypted result match the one that's been stored? If it does, then that means it's, it was the same password. If not, then it's not the same password. So encryption is something that you have to deal with in general, but definitely it's going to show up more often in the database and some of the testing there to make sure that you have and this again goes back to some of the data integrity pieces, to make sure that you are consistent in the encryption library and method that you use. Pretty much usually it needs to be across the database. So you're not having to figure out, well, this gets encrypted this way, that gets encrypted that way. If you do, that's just more testing headache, because you just have to make sure that in each specific case that the encryption and the decryption are properly paired. Any other questions? Is that sort of where you were thinking, Mike?
Yeah, I just want to make sure we touched on that, because I think that is something that really needs to be considered with data integrity when testing.
Yes, agreed. So great way to catch a miss there. So continuing sort of in this saving and loading data theme. So the first thing was, we talked at the start about the idea of this side effect that we have. So we have a function, we send some data, there's some sort of output, but along the way, it's maybe saving or loading data. So the saving side is you have to actually go to the database. When you make this call, if it saves data, look at what was saved. One, was it saved? You need to worry about, was it created if it needed to be created? Was it updated if it needed to be updated? Was it deleted if it needed to be deleted? And then within that, particularly when you think about, I guess there's two things, is if you edit, you want to make sure that you can edit every single one of the fields and save the change and see that in the database. If you are creating, then you need to be able to test, ideally, you're going to go through and test each of the fields within that record as well, to make sure that you're handling null cases properly or invalid value cases properly. And of course, obviously the happy path where you have proper values. On the whatever you save, you should be able to load that back in somewhere and verify that all of those values are properly loaded. And now in some cases, you're going to see things like audit trail data. There's going to be some additional data that you never really, it needs to appear in the database. And that's actually the only place it's going to appear, is when you're looking in the database. There's no programming interface or anything like that uses that, but that's even essentially side effects to doing an update or a creation or even a deletion maybe of data, is to make sure that the other things that need to be in place, whether it's an updated timestamp, whether it's some sort of a deleted records audit file somewhere or audit log somewhere, making sure that those things are in place, that those things are properly triggered, which we're going to talk a little bit more here and talk about triggers. We also want to make sure with the saving and loading that a partial works, so that if we do a record where we're just putting like maybe some blank values in, that it handles that properly based on the requirements. And if we load that back in, that's also handled according to the requirements. And by according to the requirements, sometimes empty values are not valid or should not be allowed. In some cases they can, and that's going to vary by the requirements. You also need to, a really key potential for a problem, which may or may not exist in the production server, I guess, is doing initial loads and essentially an empty database, which may not be completely empty, but it's sort of like, hey, I've got this new customer maintenance database and it starts with 0 customers. So you need to make sure that you can work with that you can add that first customer, that when you add that data, when you save that first record, that it also saves all of the other pieces that it needs to in order to be able to pull that record back. Because in some cases you'll see, going back to the earlier example, where you can save a customer record, but maybe you don't at that point save addresses. And so when you later try to pull that customer, you have an issue because it can't pull an address. And maybe there's it's a requirement that you have to have an address. So again, some things to look at that are just sort of like those common kind of issues you run into with dealing with databases and testing the data.
Sorry, Rob, I have one more question.
Sure.
If you go back. So for the save and load data, would you also consider adding a bullet point here for testing permissions to make sure that different account types can do the correct permissions, like they can update or not update particular tables?
Yes, you definitely want to take security into account. That's usually more of an application level thing. Although sometimes this is where database testing can be a challenge, just because sometimes there's a lot of logic in the database and sometimes there's basically none. And depending on how that goes, you may need to dig into data being updated only when it can. And that really goes to really, it's a nice little dovetail into the next slide,